According to the National Electrical Code 2020 Article 406.9b, specific requirements exist for electrical box covers used in wet locations, particularly around pool equipment. The electrical box cover needs to be suitable for wet locations and approved specifically for pool equipment applications. This means the cover has to provide robust protection against both water and dust intrusion. Additionally, the cover should not be readily removable, ensuring that it remains securely in place to maintain its protective function. The construction material of the cover is also critical. It must be made from a non-corrosive material such as fiberglass or polyvinyl chloride, often abbreviated as PVC, to withstand the harsh conditions typical of pool environments. Given these code requirements and the specifics of the situation, a pool equipment box cover is the most suitable choice. These covers are engineered to protect electrical equipment in wet and outdoor environments, making them ideal for pool pumps and motors. Regarding the cord keeper, if the box cover is sufficiently watertight, a cord keeper might not be necessary. However, if a cord keeper is used, it should be mounted outside the box and fitted with its own watertight cover. This arrangement ensures that water cannot enter the electrical box through the cord entry point. Several additional considerations are important for ensuring a safe and compliant installation. Firstly, ensure that the box is properly sealed to the deck planks to prevent water from seeping into the enclosure. This sealing process is crucial for maintaining a dry environment within the box. Secondly, use stainless steel mounting hardware to resist corrosion. Stainless steel is highly resistant to rust and degradation, making it suitable for damp and chemically treated pool environments. Thirdly, consider adding a ground fault circuit interrupter, often abbreviated as GFCI, to the circuit for added safety. A GFCI will quickly cut off power if it detects a ground fault, reducing the risk of electric shock. In summary, choosing the right electrical box cover involves selecting a pool equipment cover that meets NEC 406.9b standards, ensuring it is watertight, non-corrosive, and properly sealed. Using stainless steel hardware and implementing GFCI protection can further enhance safety and code compliance for submerged pool motor installations. Remember to consult the latest edition of the NEC and local electrical codes for the most current and specific requirements in the area. The selection and installation of electrical components near a pool requires careful attention to safety and code compliance. The National Electrical Code, or NEC, provides specific guidelines to ensure safe operation and prevent electrical hazards in these environments. Key among these considerations is the choice of the electrical box cover. Firstly, NEC Article 406.9b mandates that any electrical box cover used in a wet location must be suitable for the environment. This suitability is typically indicated by a listing from a recognized testing laboratory, such as Underwriters Laboratories, often abbreviated as UL, confirming that the cover meets specific standards for water resistance. Secondly, for pool equipment, the cover must not only be suitable for wet locations but also specifically approved for use with pool equipment. This approval ensures that the cover can withstand the chemical exposure and other unique conditions associated with pool environments. Thirdly, the design of the cover must provide adequate protection against the ingress of water and dust. This protection is often achieved through features like gaskets, seals, and tight-fitting components that prevent moisture and debris from entering the electrical enclosure. Fourthly, the cover should not be readily removable. This requirement is in place to prevent unauthorized access to electrical connections, which could pose a safety risk. The cover should be secured with screws or other fasteners that require a tool to remove. Fifthly, the material from which the cover is constructed is critical. It should be made from a non-corrosive material, such as fiberglass or PVC. These materials are resistant to the chemicals commonly used in pool water treatment, as well as the corrosive effects of moisture. Sixthly, regarding cord keepers, they may not always be necessary if the box cover provides a sufficiently watertight seal. However, if a cord keeper is used, it should be mounted outside the box and equipped with its own watertight cover. This configuration helps to prevent water from entering the enclosure through the cord entry point. Seventhly, in addition to selecting the appropriate cover, it is essential to ensure that the electrical box itself is properly sealed to the surrounding structure, such as deck planks. This sealing helps to prevent water from seeping into the box from the surrounding environment. Eighthly, using stainless steel mounting hardware is crucial for resisting corrosion. Stainless steel is highly resistant to rust and degradation, making it an ideal choice for pool environments where exposure to moisture and chemicals is common. Ninthly, adding a GFCI to the circuit provides an additional layer of safety. A GFCI is designed to detect ground faults and quickly interrupt the flow of electricity, reducing the risk of electric shock. Tenthly, regular inspections of the electrical box and cover are essential for identifying any signs of damage or deterioration. Any issues should be addressed promptly to maintain the integrity of the electrical system. In summary, selecting the right electrical box cover for a submerged pool motor involves careful consideration of NEC requirements, material compatibility, and design features. By following these guidelines, the safety and reliability of the electrical system can be ensured in the pool environment. The use of a GFCI is a critical safety measure for electrical circuits near water, such as those powering pool equipment. A GFCI works by monitoring the current flowing into and out of a circuit. If there is an imbalance, even a very small one, it indicates that some of the current is leaking to ground, potentially through a person. The GFCI quickly interrupts the circuit, typically within milliseconds, preventing a dangerous electric shock. The NEC mandates the use of GFCIs in various locations around pools, including for outlets and circuits supplying pool equipment. This requirement is intended to provide a high level of protection against electrical hazards in these areas. When installing a GFCI, it is essential to follow the manufacturer's instructions carefully. The device should be installed in a readily accessible location, and it should be tested regularly to ensure that it is functioning properly. Regular testing involves pressing the test button on the GFCI and verifying that it trips, cutting off power to the circuit. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCIs are available in several different types, including receptacle-type GFCIs, which replace standard electrical outlets, and circuit breaker-type GFCIs, which replace standard circuit breakers in the electrical panel. The choice of GFCI type depends on the specific application and the configuration of the electrical system. In addition to GFCIs, other safety measures can help to reduce the risk of electrical hazards around pools. These measures include maintaining proper grounding of electrical equipment, avoiding the use of extension cords near the pool, and ensuring that all electrical connections are properly insulated and protected from moisture. Furthermore, it is important to educate pool users about electrical safety. This education should include information about the dangers of using electrical devices near the pool, the importance of keeping electrical equipment away from water, and the proper use of GFCIs. By taking these precautions, the risk of electrical accidents around pools can be significantly reduced. Remember that electrical work should always be performed by a qualified electrician. Attempting to perform electrical work without the necessary training and experience can be dangerous and may violate local electrical codes. In conclusion, GFCI protection is an essential safety measure for electrical circuits near water, and it should be implemented in accordance with the NEC and local electrical codes. Regular testing and maintenance of GFCIs are critical for ensuring their proper functioning, and other safety measures should be taken to minimize the risk of electrical hazards around pools. When dealing with electrical installations in and around swimming pools, understanding and adhering to the National Electrical Code, or NEC, is paramount. The NEC provides specific guidelines to ensure the safety of individuals using the pool and to protect against electrical hazards. One of the key aspects covered by the NEC is the grounding and bonding of electrical equipment. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source, which helps to trip a circuit breaker or GFCI and prevent electric shock. Bonding, on the other hand, is the process of connecting different metallic parts of the pool structure and equipment together to create an electrically continuous system. This helps to equalize the electrical potential between different parts, reducing the risk of shock. The NEC specifies the types of grounding and bonding conductors that must be used, as well as the methods for connecting them. It also outlines the requirements for grounding and bonding specific equipment, such as pool pumps, heaters, and lighting fixtures. Another important aspect covered by the NEC is the placement of electrical equipment around the pool. The code specifies minimum distances that electrical equipment must be located from the edge of the pool, as well as requirements for the type of equipment that can be used in these areas. For example, electrical outlets near the pool must be GFCI protected, and lighting fixtures must be specifically designed for wet locations. The NEC also addresses the wiring methods that can be used around pools. The code specifies the types of conduit and wiring that are suitable for use in wet and corrosive environments, and it outlines the requirements for installing these materials. For example, wiring must be protected from physical damage, and it must be properly supported and secured. In addition to these specific requirements, the NEC also includes general provisions that apply to all electrical installations. These provisions cover topics such as overcurrent protection, conductor sizing, and equipment labeling. Adhering to these general provisions is essential for ensuring the safety and reliability of the electrical system. When working on electrical installations around pools, it is essential to consult the latest edition of the NEC and to follow all applicable local codes and regulations. It is also important to have the work performed by a qualified electrician who is familiar with the NEC requirements for pool installations. In conclusion, the NEC provides comprehensive guidelines for electrical installations around swimming pools. By understanding and adhering to these guidelines, the safety of pool users can be protected, and the risk of electrical hazards can be minimized. When installing electrical equipment in wet locations, such as around swimming pools, special precautions must be taken to prevent electrical shock and ensure the safety of individuals using the pool. One of the key considerations is the selection of appropriate enclosures for electrical equipment. Enclosures are designed to protect electrical components from the environment, including moisture, dust, and physical damage. In wet locations, enclosures must be specifically designed to prevent water from entering and coming into contact with electrical parts. These enclosures are typically rated for their ability to withstand water exposure, and they are often referred to as watertight or waterproof enclosures. The National Electrical Manufacturers Association, often abbreviated as NEMA, provides a classification system for enclosures based on their ability to protect against various environmental conditions. NEMA ratings are commonly used to specify the type of enclosure required for a particular application. For example, a NEMA 4 enclosure is designed to be watertight and dust-tight, making it suitable for use in wet locations where it may be exposed to splashing water or hose downs. A NEMA 4X enclosure provides the same level of protection as an NEMA 4 enclosure, but it is also constructed from corrosion-resistant materials, making it suitable for use in environments where it may be exposed to corrosive chemicals. When selecting an enclosure for use in a wet location, it is important to consider the specific environmental conditions that the enclosure will be exposed to. This includes the amount of water exposure, the presence of corrosive chemicals, and the potential for physical damage. It is also important to choose an enclosure that is large enough to accommodate the electrical equipment that it will house, while still providing adequate space for wiring and connections. In addition to selecting the appropriate enclosure, it is also important to ensure that the enclosure is properly installed. This includes sealing all openings and penetrations to prevent water from entering, and using appropriate hardware and fasteners to secure the enclosure in place. Regular inspections of enclosures in wet locations are essential to identify any signs of damage or deterioration. Any issues should be addressed promptly to maintain the integrity of the enclosure and prevent water from entering. In conclusion, selecting and installing appropriate enclosures is critical for ensuring the safety and reliability of electrical equipment in wet locations. By choosing enclosures that are specifically designed for wet environments and following proper installation practices, the risk of electrical shock and equipment damage can be minimized.